Okay, so this is question 6, the final question. Question 6 starts off by saying, let f be the function defined by f of x equals cosine of 2x plus e to the sine of x. Let g be a differentiable function. The table above gives values of g and its derivative g prime at selected values of x. Let h be the function whose graph, consisting of 5 line segments, is shown in the figure above. A starts off by asking, find the slope of the line tangent to the graph of f at x equals pi. So the first thing I'm going to do is I'm going to take f and I'm going to find its derivative. So f is cosine of 2x plus e to the sine of x. What I do is I find the derivative using the chain rule. It turns out to be negative 2 sine of 2x plus e to the sine of x cosine of x. I then plug in pi, and I just factor down, and you just get negative 1, and that's the answer. So the slope of the line changes to the graph of f at x equals 1 is negative 1. B asks, let k be the function defined by k of x equals h of f of x. Find k prime of pi. So what I first start off by doing is writing what kx equals h of f of x, and then I write what k prime equals, and I use the chain rule for this. This is purely chain rule. Mainly, the main part of this problem is just using the chain rule and the rules to find derivatives. So h of f of x is h prime of f of x times the derivative of the inside, which is f prime of x. So then we already know a lot of these values. Once you plug in k prime of pi, because that's what you're looking for in the question, it's h prime of f of pi times f prime of pi. We already found f prime of pi up here. It's negative 1, and I simply just plugged in pi over here just to show you my work. What f of pi equals, and it's 2. So k prime of pi is equal to h prime of 2 times negative 1. Now, this is the graph of h. At 2, the slope of the line tangent, as you can see, it moves 1 down in 3, so it'd be negative 1/3. So the slope of, or h prime of 2 is negative 1/3. So k prime of pi equals negative 1/3 times negative 1. So k prime of pi is 1/3. C asks, let m be the function defined by m of x equals g of negative 2x times h of x. Find m prime of 2. So as I just said previously, what we're going to do is we're going to write what m of x equals, and then we're going to use the multiplication rules of derivatives to find the derivative. So what I did was I did g of negative 2x times h prime of x plus the derivative g of negative 2x, which is g prime of negative 2x times negative 2, because you have to include the derivative of the inside, times h of x. And then I simply plugged in 2. And so g of negative 4 is in the graph, so is g prime of negative 4. H prime of 2, we already found, it's negative 1/3. The only thing that we have to find in this is h of 2. So you can use your knowledge that the slope is negative 1/3 to find that it's negative 2/3. So it's simply 5 times negative 1/3 plus negative 2 times negative 1 times negative 2/3. And you get negative 3 as your answer. So m prime of 2 is negative 3. D asks, is there a number c on the closed interval from negative 5 to negative 3 such that g prime of c is equal to negative 4? Justify your answer. So this seems like a lot of wording, but simply what you're going to do is you're going to find the slope of the of g from negative 5 to negative 3 using just a general slope formula, y1 minus y2 all over x1 minus x2. So again, I did g of negative 3 minus g of negative 5 all over negative 3 minus negative 5, and I found that that slope is negative 4. And we previously already know that by the mean value theorem, if the slope is negative 4, there has to be a value in that set interval at which the slope is going to be negative 4. And based on the mean value theorem, we can possibly say that g of x is differentiable. Oh, sorry, I forgot to add that. The mean value theorem only applies if the function itself is differentiable, And as we know, in the given information, let g be a differentiable function. So since g is differentiable, thereby, by the mean value theorem, and since that g of -3 minus g of -5 all over -3 minus -5 is -4, so that means that the slope at one point must be -4 at some value t in the closed interval -5 to -3. All right, and that is the final question. Thanks for watching.